Now we have our last question. This is the application. So we have the atomic bomb is launched upward from a tower 50 feet high. So that's going to be our starting height. And then an initial velocity of 80 feet per second. That's going to be V0. All right. So the first thing we want to do to work with throughout the rest of the problem is write our function. So the height of the object with respect to time is going to be negative 16t plus 80t plus 50, where we have our initial velocity and our initial height. How high will the bomb be 1.4 seconds after it is launched? So here, we want the height after 1.4 seconds, and the way we're going to find that is by plugging that in. Negative 16 times 1.4 squared, forgot my squared over here, and plus 80 times 1.4 plus 50, which is going to equal, let me pause this for a moment, and that's going to come out to 130.64 feet. Okay, the next part, when it says what is the maximum height, and after how many seconds will it reach its maximum? So this is looking for the vertex. Those are both vertex. And so what we're going to do is we're going to take our function from up here, and we're going to need to complete the square. All right, we need to have squared there. And so we did this process earlier, where we're going to take s of t, and we're going to subtract the 50 from both sides. And we're also going to factor out the negative 16, t squared minus 5t. That's our first step, first or second step. The next thing we want to do is we want to complete the square right here. So we want to get t, and then half of the coefficient is going to be minus 2.5. Now, how do we make sure that that's the same as what's above? T times t is going to give us t squared. T minus 2.5, t minus 2.5. And by the way, we can already answer right now that it's going to take 2.5 seconds to reach the maximum. So when I multiply these two together, I'm going to get t squared. I'm going to get minus 2.5, and minus 2.5t gives us the 5t. But then I get negative 2.5 times negative 2.5 is 2.5 squared. So that 2.5 squared is going to be 6.25, but don't forget, we also need to multiply it times this negative 16 out in front. So that negative 16 times 2.5 squared is actually 100. Negative 100. So that means in order for these to be the same, I would have to add that into this side. 6.25 times the negative 16 would mean that I'm making this 100 units less. That means this will combine to be s of t minus 150 equals t minus 2.5 squared. So last of all, s of t is going to be negative 16 t minus 2.5 squared plus 150. And that 150 tells us the maximum height. And we know it's going to happen after 2.5 seconds. Final part, after how many seconds will the bomb hit the ground and destroy all life? Hopefully not in a reality. So what's going on is not only do we have the bomb as being launched up into the air, but it's got a starting height. And so this is not to scale, of course. It's going 150 feet up in the air, but basically we launch it from a height of 50 feet. And we already determined that it takes 2.5 seconds to reach the maximum. Now, if you reason out correctly, it's symmetrical. So if it takes 2.5 seconds to get to the top, it's going to take 2.5 more seconds, or 5 seconds to get to the original starting height. But it did not start on ground level. So it's going to fall for a few more seconds, or even a fraction of a second. So the only way we're going to solve this is by setting the function equal to 0. Set the function equal to 0, and you could use either function. I'm going to use negative 16t squared plus 80t plus 50. I'm going to use this as the quadratic formula and find x that way. So negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. I will kind of leave the calculating to you. I'm going to pause for a second. And the positive answer turns out to be 5.56 approximately. Now, of course, you would get a negative answer, which would be back here. This is not one that we want to include. So our final answer here is 5.56 seconds.